Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is subtree in N-ary tree. Right. So it is a medium level problem, and the problem I believe is actually pretty decent, but the test cases for this particular problem are very weak. So like before starting the problem discussion, I just wanted to show you one thing. So this is one custom input that I created, and I was like trying to figure out different test cases. So like I'll show you something in this particular case. So you see that for this particular custom input, my code is failing. It is not failing, but the expected output is different from my output, which means the checker function or the function that they are using to generate the output is different from my code, right? So when I try to submit the same code, you will see that this particular problem will get accepted. You see that the problem is accepted, and interestingly enough, there are 225 test cases, out of which only 155 are passed, and still this problem is accepted. That means for some reason neglecting all of the test cases. And I believe the members of the Geeks for Geeks team already know about this particular issue, that the checker function is itself wrong. And I'll show you how the test case that I just showed you. I'll also explain what that test case means and how I believe that my code is correct and their checker function or their output generating function is wrong at some point, right? So I'll share my reasoning, and it might also happen by the end of the day the problem statement might get changed, or the test cases might get updated. So it can also happen that the explanation that I'm sharing right now might not work later. So I'm telling you this particular thing in advance because it had happened like multiple times in the past. So but I believe like the overall idea of the problem would still remain the same. So you can still solve the problem, and in any case you can comment down on this video, and if possible I'll be updating the GitHub code of this particular problem. Right. So for now, I believe like their output generating function has some issues, and that is why they are only checking the first few test cases and not the rest of not the rest of it. Let's see how it happens by the evening, and also that is the reason I believe that this particular question has such a high accuracy, because like even the wrong codes are getting accepted and they are not checking it on the other test cases, right? So this is the test case that we'll be discussing later on also, like how I believe my code is giving the correct output and there is wrong, right? So let us discuss what is the problem now. It says that we have been given the root of an N-ary tree. So an N-ary tree, in an N-ary tree, any node can have n number of children, right? There is no limit on how many children it can have. Like in a binary tree, it can have a maximum of 2 children. In an N-ary tree, there is no limit on that, right? So we have to count the number of duplicate subtree in the N-ary tree. Now, by duplicate subtree, they mean we don't actually have to count the number of duplicates. We just have to tell whether like 4 is present here, right? So we have to tell whether 4 is present somewhere else or not, right? So they consider two trees duplicate if they have the same structure as well as the same node values, right? So this point is very important. That is, they have the same structure and they have the same node values, right? You have to consider this point. Now, in this particular example, you can see that I'm just explaining you this particular example here only, that they say that there is a node with value 4, right, and it has only one node, right? So there is no point of discussing the structure. But since it has one node and this node also has one node and it has the value 4, so they are considered to be duplicates. Now this particular node also has the value 4 and it has the same structure as others, but we don't need to count it again. Why? Because this has already been counted, right? So as discussed, we don't have to count the number of duplicates. We just have to tell whether this node has any other duplicate present or not. If it has any other duplicate present, then we have to increment our answer by 1, right? Similarly for 3, they have number 3 has its duplicate present in the tree, so the total output will be 2 because 4 has a duplicate and 3 is a duplicate, right? So this is the whole problem. Now let us discuss this particular test case that I was trying to say. So I'll just copy it, right? So this is the test case. Now this is the way that the sample input will be given. So the first node is 1 and the second node is 2, third node is 2, and then we have 3 here, and then we have 3 and 4 here, and then we have 4 here, right? So according to my code, the answer should be 1, and according to their checker function or their output generating function, the answer is 2. This is my answer, This is GFG answer, right? So according to me, like what is happening is this node is considered to be a valid duplicate node because 4 is also present here, right? But I believe that the second node that they are counting is this particular one, 2, 3 and 4 and 2, 3 and 4, right? Why? Because they have counted that 3 and 4 are present in the subtree of 2. Here also 3 and 4 are present in the subtree of 2, but we can clearly see that these two subtrees do not have the same structure. They have the same node values, that 3 and 4 are present in the subtree of 2, but they don't have the same structure, overall structure, right? I'll also explain how we can generate the answer 2 for this particular problem, but we don't need to do that now. I believe that this would be the correct approach, that we need to only count only one subtree in this particular case, because these two subtrees have a overall different structure. So I don't think that this should be counted. Now, if the question changes that we have to consider only the nodes only the subtrees which have the same node values. For example, 2 in this particular tree, 2 has the nodes 3 and 4 in subtree. Here also 2 has the nodes 3 and 4 in the subtree, right? So in that particular case, we can consider the answer to be 2, but since the structure is different, the answer should only be 1 in this particular case, right? So this is what I believe. So if we actually talk about the constraints for n are, then it's part 3, and we can easily form an n square solution. So what are we essentially going to do? So what we'll do is we'll start from the root node and we'll start traversing to the leaf node, right? Once we have got to the leaf node, we'll start building the subtree from the current leaf node. So our main idea is to build the subtree from bottom up, right? From the bottom up. Now, once we have got the subtree, we'll increment. For example, we have got the value of the subtree at node 2. We'll increment its frequency. For example, let me just, in this particular case, I'm using a vector of integers, right? So, for example, there will be a sequence of integers, like let's say 1, 2, 3, minus 1, 1, 2, right? For example, like this, we'll increment the frequency of this particular integer sequence, right? And since this particular integer sequence is denoting a unique subtree, then this particular value will help me find the number of subtrees which have a frequency greater than 1, and that number of subtrees which have a frequency greater than 1 will help me know the count of it, right? So this is what we're essentially going to do. We're going to start a bottom-up approach, and we're going to form the subtrees one by one and increment their frequencies. In this particular case, I'm using a vector of integers to represent a subtree. Now, how are we actually going to represent a subtree? So let me just show you. I made some changes in the code, and also so that I can print this all the subtrees type forming. So we are interested in these two subtrees which are starting from 2, right? So let me just show you this particular example. So we are going to discuss this particular subtree that we are forming. So this is the right subtree and this is the left subtree, right? Let me just show you how I'm trying to form the answer. So when I push any node, let's say node, right? I push -1 with it, and I traverse all the children, and then at the end I push -1 again, right? So this is how a node will be represented, and its subtree will be represented between two -1s, right? So I believe that this is not any standard traversal, but it will definitely help me preserve the structure of the subtree. Why? Because I'm trying to write the node first, and I'm trying to denote its subtree between two -1s, right? So this is what I'll be doing. So let's say that this is the first one is the right subtree. Let us discuss how it can be the right subtree. So for example, the first element that we have 2 is here. So this starts, this is the starting of 2, this is the ending of 2, right? Let us denote it like this. Now we have a new node 3, right? So 3 doesn't have any children, so this is the starting. So this is the starting of 3, this is the ending of 3. Similarly, 4 doesn't have any children, so this is the starting of 4, this is the ending of 4, right? Similarly, if I talk about this particular test case, this is the starting of 2, this is the, let me just write it as 2s, this is the ending of 2. Similarly, when I go to this particular 3 in the left subtree, then this is the starting of 3, 3 is starting, and this is the ending of 3, 3 ending, right? Now, since I have 4 inside the subtree of 3, then I'll have the starting of 4 and the ending of 4, right? So this is how I'm trying to preserve the structure of the subtree. So in both the cases, you will see the overall vector that we get has a different structure, right? So this will definitely help you to preserve the structure of the subtree. Now what I'm doing is, I'm telling you again, I'm pushing a node. So for example, I've pushed a node, I push -1 with it, and I traverse its children, and I push -1 again. So the elements between these -1 will denote the subtree of this particular node, right? And in case the two subtrees are different, then the overall structure between these two subtrees will be different. So you see that the 2 and -1, let me just write it more clearly, that the 2 and the -1 here and the -1 at the ending is same in both the cases, because both 3 and 4 are in the subtree of 2, but the internal structure of these two are different, right? This is how we are going to distinguish between the subtrees. This is something that is not happening with the GFG code, right? So that is why I wanted to share this thing with you, and that is why they are printing the answer to be true, right? So like the overall problem is not very difficult. It's a decent, interesting problem, but I would say like due to the incorrect test cases, I believe a lot of wrong submissions are also getting passed. And there is also one more approach that I wanted to discuss with you. So what you can do is, you can also store the in and out times of each of the nodes. And since we can do an n square operation, what you can do is, I would want you to try this approach on your own. So once we store the in and out times of all the nodes, what you can do is, for example, 3 and 4 are present in the subtree of 2, right? You know this. But if the structure is different, the in and out times of both 3 and 4 in both the subtrees will be different. So let us assume that the in time, let's say in time of 2 is let's say 0. In time of 3 will be 1, and in time of 4 will be 2, right? So similarly, out time of 4 will be 3 in this case, out time of 3 will be 4 in this case, and out time of 2 will be 5 in this case, right? So the out time, in and out time of 2 should remain the same. I believe it should be 0 and 5, but you will see that the in time of 3 is 1, out time of 3 is 2, right? In time of 4 is 3, in time of 4 is 3, and out time of 4 is 4, right? So you will observe that if the structure changes, the in and out time of the node also gets changed. So what you can do is, you can also keep a track of what are all the nodes in the subtree of any node. So for example, in the subtree of 2, the nodes are 3 and 4, and you can check its out time. So for the node 3, the in and out time are 1 and 4 respectively, and in this particular case, the in and out time are 1 and 2 respectively, right? So if the in and out time of the root node is itself changed, then it means that the structure over the number of nodes in the subtree of this particular 2 are different, right? But you can also do it like this. You can initially check whether the nodes are the same, and if the nodes are the same, to check the structure, you can separately run a loop to check all the values and compare them if they are equal or not. If all the values are equal, that means the structure is the same. Otherwise, there is some difference in the structure, right? Alternatively, you can also use this method to first push the node into a vector, and then push -1 in the beginning, -1 at the end, and keep all the elements or all its children inside between these two -1s, right? So this would be the solution we'll be going with. We'll be maintaining a map of vectors, right? So we will be storing the frequency of these particular vectors. Now let me just show you the code. So this is something I just printed on my own to just show you how are the subtrees are getting printed, because while recording the video, I found it very difficult to explain you the overall working of this particular approach. That is why I thought it would be easy if I just show you how the subtrees are being formed, right? So now the code is not very difficult. I've created a map of vectors, right? So it will store the frequency of these vectors. Now this is my DFS function, simple DFS function, and I'm calling the DFS from here. So what I'm essentially doing is, I'm just making the current vector as node.data, and the second element is 1. So this is the current node, right? And this is -1. So -1 is indicating the start of its children. Now I just traverse through all of its children, and I find the subtree vector from this particular DFS child. So each subtree will be returning a vector. So I'm getting a vector from its children, and I'm appending all the values in its children to the current vector. After I have traversed all the children, I just push back -1 to the end of this current vector, and I just increment the frequency of current and return the current vector. So you will see that each node will return its vector or its subtree vector to its parent, right? And the parent will include its subtree vector into its children and append it at its current vector. At the end, after all the children have been traversed and I have formed the complete subtree, I'll just increment the frequency of the current vector and I can just return the current vector. So this would be my simple DFS function. Now at the end, what I can do is I can initialize my answer with 0, and for all the values that have a frequency greater than 1, I'll increment my answer by 1. So this is a Boolean expression, and if it is true, it will return 1, otherwise it will return false. Now at the end, I can just return my answer, and this will be the solution of today's problem of the day, subtree in N-ary tree. And I repeat that the problem statement might get changed later on, or the test cases might get updated. So it is very well possible that this code might not work later. So I request you, if any such thing happens, then like you can comment it down, and I'll try to update the code on my GitHub if possible by the end of the day, right? So I hope that you guys were able to understand the solution. I tried to give you all the insights that I had on this particular problem, all the things that I found wrong, and how to correct them. And I hope this video was useful for you. And if you find this video interesting, you can drop a like, and don't forget to subscribe to this channel. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So I see a lot of people who watch these videos regularly have not subscribed yet. So if you're one of them, do consider subscribing and share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.